My name is Tom Caswell. I'm co-chairing the plenary sessions along with Hannah Eisman. The format of this is going to be a series of short 3 to 5 minute talks, providing updates from core projects of the ecosystem. Our first talk is by Chuck, telling us about the current state of Numpy and where things are going. And next is Pandas.
So do I see my slides anywhere?
You do.
Okay.
And
I hit it?
left and right.
Okay. Yep, so I'm just introducing Numpy very quickly. What is Numpy? It supplies the basic data container used by most of the numeric programs associated with Python. So it's an n-dimensional array object. We have also tools that will write interfaces, C interfaces for Fortran and C++ and C code. Of course, you have Python does the same thing for C and C++ nowadays. We have linear algebra, basic singular value decompositions, solution of linear equations, and so on. Fourier transform and the basic random number capabilities. We don't have as many distributions as SciPy does. You can go online and get the rest of the information here. I just have those links there for you. So Numpy typically releases about twice a year. We've tried to make it faster now and then. It never works out. It always comes back to 6 months. You might think that software as old as this tracks back to about 2005, would be pretty mature and there wouldn't be much left to do. Well, that's not right. It's constant maintenance. We probably merge about 1,000 pull requests per year. And I don't see that. That's getting bigger. I don't see that going away anytime soon. The last 3 releases, we've done a fair amount. We now have temporaries reuse, so that speeds things up a little bit. We used to overwrite on in-place operations all the time if they overlapped inputs and outputs. That had weird results, so we now have detection of that case and generate a temporary so we don't overwrite. We handled different encodings now for files for input and output. We're trying to prepare for dropping Python 2.7 at the end of the year. We have better printing of, some people wouldn't like that. We have better printing of the arrays and scalars, at least we hope we do. We have an array ufunc. This allows people to override the ufunc's behavior with their own particular subclasses of Numpy arrays. We have block function, which I think is a much nicer interface for generating arrays out of blocks. Einsum, which has been really a fantastic function Mark Wade gave to us, now uses BLAST when it can at the lower level. And we've also switched to PyTest instead of Nose because Nose is no longer maintained as a testing framework. We have 2 people who are actually employed to work on Numpy for the next 2 years. This is something new. Usually you did it for free. Certainly I've done it for free all my life. So we're going to see how that works out and going forward. We're trying to sort of see whether funding works for open source projects, and I hope we're successful in that. Future plans, we have a couple of NEPs. You can see these out on the net to see what we're proposing to do. We will drop support, as I said, for 2.7 at the end of the year. We're trying to extend the array ufunc mentioned earlier to an array function, which allows overriding of a lot of more functions in Numpy. This allows different people to have different behavior for but use the same function names as Numpy, so you only have to write the code once. We're going to have new random number generators. We were stuck with always having the same stream coming out. We're giving that up. This allows us to improve and make faster generators and algorithms, because we can now change that. And we're working on making the advanced indexing a little more sensible. That's one of the hard things to understand about NumPy. Other future plans, these are much up in the air here. But we do want to do more code coverage for the tests. We probably want to have more extensible D-types and standardized missing values. Okay, so. That's it? Yep.
Hello. Hello, say hello to Joris from Pandas.
Okay, so I'm going to give a quick update about Pandas. Pandas is a data analysis library providing the data frame object mainly. Our current development focus, and I listed here a few of the new features in the releases of the last year or something. So we have, for example, the improved Parquet input-output. You can read and write Parquet files. Also, JSON table schema or styled Excel output, a lot of things. Another thing that we added was support for an interval type, and many other smaller things. And something that we are currently working on is also to make it easier to extend Pandas with custom types. But I will come back to that. Apart from new features, we're also focusing currently on trying to clean up our API. Hopefully, we have already said that before, but we hope to release call something 1.0 early next year. And that means we are going to try to remove panel to focus on 2D tables and some other deprecations and cleanups. But I wanted to focus a little bit more on the one new feature that we are working on to make it easier to extend Pandas. If you want to store certain type of data that doesn't fit in one of the existing data types, like you want to store geometries in your table, or you want to store IP addresses in a table, to make that easier. So the last release of Pandas includes the extension array interface, as we called it, where you can define an array-like, a 1D array-like, and as long as you provide a certain set of methods that we need, you can store those data in a Pandas data frame, and almost all functionality works there. Just a small example, CyberPandas and GeoPandas are two such libraries that do that. And you can see there, if you check then the D-types of your data frame, they're actually new D-types. Another one I just want to mention is, for example, Uwe Korn has been working on implementing a string data type, a proper string data type based on Arrow in another library called Fletcher. And we also hope to have optional integer with NA support using the same mechanism.
So I'm going to introduce myself. I'm Tom Caswell from Matlablib. So I'm going to tell you we're rapidly approaching Matlablib 3. The biggest feature in Python and Matlablib 3 is we're dropping Python 2. The goal is to have an RC candidate out by the sprint at SciPy. We have the version 2.2. We're going to treat that as a long-term support release, so it's going to keep getting critical bug fixes until 2020. In terms of release schedule, we're trying to get to a 6-month release cycle. Ours tends to be slower. So 6 months on feature releases off the master branch, and as needed on bug fixes for the long-term support. So this is a quick rundown of new things that we added between 2.1 and 2.2. We finally have a constrained layout manager, so you can just put text and axes on the figure and say, please make them fit as best you can. And it's using Kiwi, which is the same thing that underlies a lot of the Jupyter layouts. We now have native support for datetime 64. If you're a heavy Pandas user of datetimes, I think you've seen these exceptions. We now, in addition to AG, which is the rasterizer we use, you can also, all of our GUIs now support a Cairo backend as well, if you want to use that. The TK AG backend works with SciPy, if that's a thing people are into. A variety of performance improvement. So ticks are now much faster. It turns out ticks are one of our slowest things in the code base. We now support string categoricals. This was Hannah's Google Summer of Code work. So if you do plot list string A, string B, string C, it will do the right thing. We've had major improvements to polar plotting. And if you want strictly reproducible plots, we can get you that for PostScript, PDF, and SVG. Work that's going to be coming in 3.0 in addition to the dropping Python 2. We've had a tremendous amount of documentation work recently. The constrained layout is still improving. We've added cyclic color. There's a cyclic linearly perceptive color map. If you use grid spec, that's now starting to become more embedded in all of the subplots. Contour and contour F behave consistently, so they pick the same number of levels for the same data. And all of the hold machinery has been fully removed. And that's it. All right. Our next speaker is Andy Mueller, who tells us about scikit-learn.
Thanks. Sorry. Yeah, so I'll be talking about 0.20, which is not released yet. So I'm going to talk about the next release and then what comes after the next release. We are hoping to put out a release candidate for 0.20 probably next week after the sprints. So just a very brief overview of what scikit-learn is. So scikit-learn is a machine learning library. It has lots of tools to build machine learning models, evaluate machine learning models, build machine learning pipelines, particularly focused on supervised machine learning. So usually you have some data set with some desired outputs that are labeled, that you build a model from these using model.fit, and you can then use this model to make predictions on new data. And so one of the things that's kind of nice about scikit-learn is that we have a very consistent interface that brings all of these different modeling steps together using mostly fit, predict, and the transform method. Okay, so what's going to be new in the next version? So other people talked about their release schedules. Our website says our release schedule is 3 months. For the last 2 years, it has been every year, I think. We hope we can speed it up a little bit more. It's hard to make releases. So this will be the first release in like a year, and there's going to be tons of new things in there. I mean, there's probably hundreds of PRs, so I will just focus on 2 things that are like maybe small compared to all the things that were done, but that I think really improve usability. So one of them, which has been seems easy, has been worked on for years. Now it's the one-hot encoder for strings. So if you're familiar with the one-hot encoder, it encodes categorical variables like strings into a 1 out of n encoding that scikit-learn can work with, because scikit-learn basically requires some float representation for all data. And until now, this only worked with integers, and also it worked really weirdly with integers because that's how I coded it like 4 years ago. Now it works much more nicely and with arbitrary data types, in particular with strings. And so you can use categorical variables much easier. So this is one thing that helped us support like what you call heterogeneous data types, or tabular data, where each column has a different data type. So this improved support for categorical variables. We also have an addition that improves putting together different transformations and different preprocessing steps for different, basically, columns in your data. This, and also the one before, has been mostly worked by Joris, who ironically just was here talking about the Pandas stuff. So this is mostly his work. And so we have this new column transformer. The column transformer allows you to pass into either a Pandas data frame or a Numpy array, or something similar to that. And then it allows you to specify masks or sets of indices of columns to which a particular transformation should be applied. So for example, here's the Titanic data set, and we have two numeric features, age and fair, and then we have some transformation we want to apply to that. Then the categorical features embarked, sex, and p-class, and the column transformer allows us to apply one transformation, namely the numeric transformer to the numeric features, and the categorical transformer to the categorical features, and we can specify to drop all the remaining columns. And so here you can see that each of these transformations, again, can be some complex thing that is built up out of other components. Like here, for the continuous, it's imputation and standard scaling. For categorical, it's a different imputation strategy and the one-hot encoder. So these two things are sort of seem simple, took us years to get them right, and I think they will make the work for a lot of people much easier. So what's next? So what's going to come in the next release? One thing I'm really excited about is having even more support for Pandas. So this column transformer already adds some sort of Pandas support. I hope we can integrate a little bit further in the future. In particular, make use of the column names of your input and track how these columns get transformed within a pipeline. For example, if features are selected or features are re-encoded so that you can see for the final modeling step which coefficients of the model correspond to which input features, for example. Well, right, that's it.
Right. And next we have Mike Sarahan tell us about the current state of Conda.
All right, hi everybody. So I really want to tell you more about the ecosystem rather than Conda itself, because Conda is a tool that, like, as long as it just works, you don't care about it. So really what I want to tell you about is how the whole ecosystem is getting better. And CondaForge in particular is growing as the standard community place to collaborate on recipes and build software. So we've grown to about 5,000 packages on CondaForge. We have about 1,000 contributors. And in this past year, we've gotten this amazing thing called the auto-tick bot. And what it does is it watches for new releases on your CondaForge recipes, and it'll update your recipes for you. And all you have to do is merge a PR. So that's really helping us stay current, which has been kind of one of the major bottlenecks to Conda packaging, is just keeping in sync with the upstream stuff. On the Anaconda side, we released Conda Build 3 last year, which has greatly improved our ability to automate stuff. We can template many more things in very creative ways. We have build matrices. We include a lot more metadata that makes packages easier to incorporate in different ways and easier to use intelligently in different ways. It also allows us to support many different varieties of packages. So say you want to build one variant with MKL and another with GPU support and another with different GPU support. We're growing that ability. We introduced compilers, so we can now support C++, 11, and 14, and whatever your heart may desire. This has also given us way, way better security and better optimization options, so you guys will enjoy that. The other major switch we've done in the past year at Anaconda is we've switched to using CondaForge recipes as the basis for all of our recipes. And the goal there is to keep the entire community together, and we can contribute our work to the community and vice versa much more easily. So that said, there's still a lot of pain points. A lot of people still have pip instructions in their tutorials, and you guys who run Conda may know that that can break things in very fun and creative ways. We're going to work on continuing to push for ways that either prevent damage from being done or do things smarter. Incompatibility between channels is a big concern of ours. Thanks. And we're working on ways to keep defaults in Conda 4 pretty much binary compatible. And so unifying the recipes and unifying the compilers should take care of that. Documentation always needs work. We're going to continue working on that. We'd love your help if you can do that. And we're also working on ways to handle the system-wide coherence. And what I mean by this is when you rebuild something low level, you often need to rebuild everything above it, thanks to binary compatibility. So we're working on ways to do that. And yeah, this is kind of our plans for how to accomplish that. Thank you.
So the speaker is Jason from Jupyter.
That won't work. Only 5 minutes, you've got to write down every word. All right. So as you know, Project Jupyter develops open source software, standardizes protocols for interactive computing across dozens of programming languages, and defines open formats for communicating results to others. Jupyter in the community has continued to grow in breadth and depth. There's been many new exciting developments from the community. For example, the Zeus C++ kernel framework from the community is making many interesting kernels possible, including an interactive C++ kernel, as well as a new R kernel called Juniper, complete with Juniper widget support. From the community notebook front ends, Interact now runs in the web browser. CoCalc has a notebook front end that supports real-time collaboration. BeakerX just released 1.0 with JVM and Spark support and polyglot programming, and culminates their transition to being built on top of the Jupyter Notebook and the Jupyter Lab code bases. We welcome all these projects and many more from the community. I've picked just a few highlights from Project Jupyter itself to talk about today. First, over the last year, we've had 3 new additions to the Jupyter Steering Council, Anna Ruvalcaba, Afshin Darian, and M. Pacer, and we thank them for their service. Jupyter Lab, the Project Jupyter next generation web front-end and successor to the Jupyter Notebook is, as of this last February, ready for users to use for their daily work. Jupyter Lab's an entirely new code base, 4 years in the making, originally started as a collaboration between Bloomberg, Anaconda, and Project Jupyter. It comes with many tools for scientific workflow, such as the Jupyter Notebook, with Jupyter widgets support, console, terminal, text editor, grid viewer. These tools all work together with many other tools that come with Jupyter Lab to make many different workflows possible. We're working on real-time collaboration, collaborative editing, and we're stabilizing the extension API right now for the Jupyter Lab core components. So extensibility is a core principle for Jupyter Lab, and many community extensions are also being developed, even while the extension API is still being stabilized right now. So we have things like a diagram editor, other file viewers, variable inspector, and many even more radical workflow experiments. And Jupyter Lab is in the process of being adopted by many organizations and large-scale scientific efforts. Jupyter Hub and Binder are growing tremendously. Jupyter Hub provides a platform for multi-user scientific computing, including Jupyter Notebooks. One deployment at Berkeley is a computational platform for tens of thousands of students, and Jupyter Hub is being adopted by many organizations as the way to use Jupyter for large organizations. Binder, which turns a GitHub repo into a live computational environment with a single click, launched a completely new rewrite last year. You probably noticed many projects having this launch Binder little icon that when you click on it, immediately launches a free custom scientific computing environment complete with the libraries and the data and the notebooks and the code necessary. So here's a graph of the weekly sessions in Binder since the beginning of the year, and you can see we're about 40,000 sessions a week right now. For community meetings, we had a great success at JupyterCon last year. We invite you to join JupyterCon this year. It's August 21st through 24th in New York. And we also invite you to come to the Open Studio Community Sprint Day on August 25th. We call it Open Studio to communicate. It's a time that you can come and work on a Jupyter project, but you can also come out and work on your own project that's Jupyter related and sit side by side with community members. And today I'd like to announce a call for proposals for a new series of Jupyter community workshops made possible by generous support from Bloomberg. These workshops bring together 1 to 2 dozen community members, core contributors for high-impact strategic work and community engagement on focused topics related to the Jupyter core mission. You can see the Jupyter blog post that just went out about an hour ago announcing this for details. The key is the first round of proposals is due August 1st. And finally, Project Jupyter was honored to receive the prestigious Association of Computing Machinery 2017 Software System Award. We're humbled to join the list of recipients that include some of the major luminaries in computing history like Xerox Alto, the Apache Group, Unix, GCC, Ingress, the predecessor for modern databases, PostScript, Tech, S, the predecessor for R, TCP/IP, the web, Mosaic, Java, and many more, and now Jupyter. Thanks. We want to emphasize that we view this at Jupyter, at Project Jupyter, as an award to the entire community and belonging to the entire Jupyter community, including the contributors and the users and the supporting organizations. Those are what make Jupyter what it is today. We view it as a tremendous affirmation of the work that we are all doing in the open source scientific computing and the principles for which we stand. So please join me in giving you and the person next to you a hand for a job well done. We're excited moving forward.